I'm going to be talking about segmented angle properties and what I call the picture given properties. Now these properties, we can use them when looking at a picture. So the first one is the vertical angles congruence theorem. If I see a picture like this, I automatically know that angle 1 and angle 3 are vertical, and we know that they're also congruent. So I can write that angle 1 is congruent to angle 3, and the reason for writing that down is my vertical angles congruence theorem. So if I see a picture like this, I can automatically say that we have vertical angles and that they're congruent. Well, we also have another set of congruent angles, or vertical angles, which is 4 and 2. 4 and 2 are vertical, so they are congruent. So we can also state that angle 4 is congruent to angle 2 because of the vertical angles congruence theorem. So we actually could write two statements down just from looking at this picture, and that we can see that we have vertical angles. My next one is the right angles congruence theorem. If we notice, we see that little right angle box, that square, and when we see that square, and only when we see that square, we know that that's a right angle. And we know that right angles are 90 degrees, and therefore they are congruent. So we can state that angle A is congruent to angle B because of the right angles congruence theorem. And we only can state this when we see those little boxes, the right angle boxes. Our next one is our angle addition postulate, or AAP. Now you might know this one a little bit better as part plus part equals the whole. Okay, so that's our angle addition postulate. We can add our parts together and equal the entire thing, the whole thing. An angle addition postulate only deals with measurements because we only can add with measurements. So we're going to take the first part of this angle, which is angle 1. So we're going to say the measurement of angle 1 plus the other part, which is angle 2. So we can say measurement of angle 1 plus the measurement of angle 2 will equal the whole thing, which is x, y, w. So the measurement of angle x, y, w. So angle addition postulate is adding our part plus our part equals our whole. So our reason for writing that down is angle addition postulate. Angle addition postulate. Okay, so that's our part plus our part equals our whole, and we only can use measurements when adding. Our next one is our definition of angle bisector. And definition of angle bisector is a little different because we have to have this statement that I've highlighted right here. I have to tell you that we have a bisector to be able to state that we have the definition of angle bisector. So if I give you this statement, the YZ bisects XYW, then we're allowed to use definition of angle bisector. Now what a bisector does, it cuts it into two equal or congruent parts. So if YZ is bisecting this angle, we can say that 1 is congruent to 2. So we can say 1 is congruent to angle 2, and we can write down the reason as the definition of angle bisector. Okay, and we only can use that if we have a statement that we have a bisector, so that's a special one. Now our next one is a segment addition postulate. Just like the angle addition postulate, we're going to do the part plus the part equals the whole thing. Except now we're adding segments. So we're going to take the first part, which is WY, plus our other part, YZ, and we're going to set it equal to the whole thing, which is WZ. And since we're adding our part plus our part equals our whole, and they're segments, our reason for writing this down is our segment addition postulate. Segment addition postulate. All right, our next one is definition of midpoint, and this is very similar to angle bisector because to use definition of midpoint, we have to have that the midpoint is stated. I have to say that y is the midpoint of line segment YZ. If I don't tell you that there's a midpoint, then you cannot use definition of midpoint. But since I told you that y is the midpoint of WZ, we can say that these two pieces are congruent because midpoint's like a bisector, cuts it into two congruent pieces. So we can state that WY is congruent to YZ. And the reason is the definition of midpoint. We only can use this when I state that there's a midpoint. So you look for that in your given. Okay, so that's your definition of midpoint. Now this next slide is just a little bit of practice, okay? And we're just going to state which reason can we use using the information that's given in the picture. Well, number one, I tell you that CE bisects BCD. Well, if I give you a bisector, we definitely know that we can use the definition of angle bisector. And if we look at this picture, we also can use angle addition postulate because we can add part plus part equals whole. So we can use more than one property for one picture. Now our next one for number 2, if we look at this, the only property that we can use is our vertical angles congruence theorem. All right, and our very last one, I tell you that N is the midpoint of MO. So the only thing that we can use, or well, one of the things that we can use is the definition of midpoint. And we actually can use the segment addition postulate as well because we can add those pieces together to equal the whole thing.